Hello. We are solving different concepts of mathematics under the heading Decreations Mathematics, which is a playlist of the YouTube channel Decreations Resources. We have been looking at complex analysis and especially Cauchy's theorem, where we have solved a couple of problems using this theorem previously. And now we are going to solve one more problem. Here f of z is 1 upon 2z square plus 1. Notice that in the previous case, where we had taken f of z as z square upon z minus 3, the function was analytic at all the points inside and also on the closed curve C, and hence the answer was automatically 0. Similar situation was there for the function log of 1 plus z, so answer was 0 as well. Now in this case, we are looking at the function 1 upon 2z square plus 1. Recall that Cauchy's theorem, which is also known as Cauchy's integral theorem or Cauchy-Goursat theorem, in honor of Goursat, who had also made some additions to it. It says that if f of z is an analytic function in a simply connected region D, then integral of f of z dz over C is 0 for every closed contour C contained in the simply connected region D. Now look at this particular function, f of z is equal to 1 upon 2z square plus 1. Now where is the denominator going to be 0? When you want to check whether the function is analytic, you need to know where this possible singularity can be. When you look at it, you understand that the answer is not going to be automatically 0. You will have to evaluate it. In order to do that, you can write 2z squared plus 1 by taking out 2 as common as 2 into bracket z square plus 1 by root 2 whole square. Now this term z square plus 1 by root 2 whole square can also be written as product of two terms, namely z plus I by root 2 and z minus I by root 2. Now we'll make use of partial fractions here, so that using that you will be able to write it as 1 upon 2 root 2 integral of I upon z plus I root 2 minus I upon z minus I upon root 2 and dz, of course. So this, when you solve it further, you can take out I upon 2 root 2 common, and in the integral there will be two terms. One is 1 upon z plus I by root 2 minus the second term, which will be 1 upon z minus I by root 2. So here if you evaluate it, you will get it as I by 2 root 2 into 2 pi I minus 2 pi I, what you can see here. And that leads you to 0. So that is how the answer is going to be 0.